Yeah, so career day, there's something for you guys to do in every class. It takes about 20 minutes. It is hard to get you to context switch, so I'd rather get some lesson stuff in and then do the, all I want to get through today is what you should have seen in precal last year. Geometric series with numbers, just numbers. So a series, you know the difference between a series and a sequence? Sequence is a list of numbers. A series is that list of numbers added up. And an infinite series, you're adding up numbers forever. And notationally, just checking that this is maybe familiar. That subscript just means position in line. A sub 1, A sub 2, A sub 3 doesn't mean A sub 4 is 4, A sub 4 is Roman. So the value of that element is Roman, it's the fourth one in line. And A sub n is just means the nth dude down the line. You can't be 4.5 in line, you can't be 7.3 in line. This notation, the sigma means sum. This thing down here is an index, means it starts at, please be careful to read the number. Computer science, it often starts at 0 or 1, but they can be funky and be like, you know what? We processed this many things, the system broke at this point, drop in at k equals 25 and start processing again. And this k sub 1, then 2, then 3, keep going up by 1 until you get this end number. Clearly, you're never going to get to actual infinity. So notation in terms and it's familiar enough that you're not going to like be allergic. So the series is that list of numbers, and this is my analogy of it was the sequence is the list of numbers, and sequence is the list, series is the sum, and we can model the series by using an integral. Okay, this I think is finally on the map. Oh no. Okay, AP exam will sometimes say, give me the first partial sums. So what's S sub 1 is just what is the first term. S sub 2 is add the first 2 terms. S sub 3 is add the first 3 terms. And then S sub infinity, which I actually write out, no one else does. That's the infinite sum. And if I can add stuff together forever and ever and ever and get a finite number, we say that that sum converges. If I don't get a single finite number, we're going to call it divergent. Okay, so find the first six partial sums. What do we get? Some of you are looking at it like, really? Kathy, what's the first one?
2 2.
Christy, what's the next one?
0.
Max, what's the next one?
2.
Naomi, next one?
0.
Julia? Claudia?
0.
Okay. So there seems to be a pattern. Stella, you get the hard question. Is this sum going to converge when I get to infinity? Am I going to have a single number that is the sum? Then what do you think? You're going to have a finite, like, is there a sum? And he said no. With attitude, though, I'm not sure that was confidence. Kyle, what do you think?
I don't think it will either.
Okay, so if I was to ask, what is that sum? If you said, yes, there is one, would you tell me that it's 0? Or would you tell me that it's 2? Is infinity even or is it odd? Yes, it is. All of those, both of those. Sometimes people are like, well, what if I say the sum is 1 because I'm going to average them out? Then you are wrong 100% of the time. So this one, you guys hate this one. It diverges. It's called oscillating. It goes between a few predictable values, but it's not a single specific thing. So this one diverges. In the past, Algebra 1 actually, you worked with arithmetic and geometric series. Is this an arithmetic or a geometric series? If it's, okay, what makes something arithmetic, what makes something geometric? One of you said something. What makes something arithmetic? Yeah? So in arithmetic, it's a line. It's where you're adding the same thing each time. So the first term would be 3, then 4, then 5. You're adding and subtracting the same thing each time. That's arithmetic. Ray, what makes something geometric?
You have a number of ways with power over and over again.
Okay, so difference by a ratio. So like 2 to the x, so algebra 1 we called it exponential, but that would be 2, 4, 8, 16. So to get the next term, you're going to multiply or divide by the same number each time to get the next 2 down the line. Okay. Is this series on the board, is it arithmetic, geometric, or something else? Amelia?
I was going to say arithmetic. Geometric.
Okay, why is it geometric?
Because we're multiplying by -1.
Okay, we're multiplying by -1 each time, yes. And they use the word R for ratio, we're multiplying by -1 each time in arithmetic sequences. It's D for difference. Okay. This series, arithmetic, geometric, geometric. Why is it geometric?
Because you're multiplying by.
I need to be multiplying by the same thing each time. So this one is on your sheet. Can you guys try and figure out converge? And if it does, what does it converge to? Any idea, Roman? 0.7 with a hat, we don't do hats. I want to know the fraction or something. Yeah. Why do you know that?
I can't remember from.
It's a pattern that you kind of know from just maybe playing with the calculator. Okay, yeah. Pre-cal last year, you should actually like solidly know why, but yeah. I want to show you a proof. I believe I put it on paper. I did not. Oh, I did. You don't need to be able to do the proof. I just want to show you. So can you guys look up for a sec? So here's the sum of the first n terms. And what makes a geometric sequence is we start with some value and we multiply by the ratio each time. So there's my list. I'm gonna multiply by r on both sides to everybody and then subtract. So in subtracting, these guys conveniently go away, including the dot dot dots and that. Factor out that s sub n and solve, I get this thing. Is there anything that will make that 0? Could that ever come out to 0? Like if r is 2 to the infinity, that's bad. So 2 doesn't work. And probably bigger than 2 doesn't work. What about a half? Geometric series, it's also called, if it was a graph of a line, y equals 1/2 to the x. What's that look like? Y equals 1/2 to the x. It's exponential decay, right? So that guy's gonna go to 0, this guy's gonna go to infinity. Where does it break? Where does it change?
1.
See?
1.
So is, like in P series, it broke at 1 also. When it's equal to 1, is it gonna be infinity or, well, when it's equal to 1, does it go this way or does it go to 0?
Just stay at 1,
Just stays at 1. But for what I wanna do here, I want it to go to 0. So I need r to be less than 1. What if it's negative 1/2? It's gonna go here, here, here. If it's negative, is it still gonna, it's gonna, the graph is gonna be crazy, but it's still gonna go to 0? Okay. So in that proof, if that guy, if the absolute value of the ratio that I'm multiplying by, absolute value of that is less than 1, my infinite sum, is gonna be this. Is that written on there? Yes, the very bottom of the page, it says, not that. infinite sum is that first term over 1 minus r. They should have done this in pre-cal last year. Geometric series. You do have all of 6 problems of homework from the textbook. I'm not sure which 90 it's called. It's not a 90, they 101 according to this. So we have like 9 more minutes before career day starts. So looking at the packet, can you guys try those 3? I kind of recommend listing out the first 3 or 4 terms so that you can see what it looks like. I just wrote out the first couple terms, like, I don't think you guys need this much, scaffolding, but, just showing you, okay, when n is 1, what is the number? When n is 2, when n is 3, when n is 4. 3 plus 3 halves plus 3 fourths plus 3 eighths. Then it's a geometric.
Yeah.
Adrian, what am I multiplying by if it is geometric? Because 3 times a half gives us that. 3 halves times a half gives the next one. A hint, look at the thing that's being raised to a power when it's in that sigma thing, it's probably it. So Evan, it is geometric. It is infinite because that infinity symbol's on the top. Is it going to converge to something? Because what?
R values less than 1, so
Where does the R values less than 1? Cedar, what's going to converge to?
It's gonna converge to 6.
Which we take the first term, which was 3, divided by 1 minus r, 3 divided by a half, 6. Okay. the other two, can you guys write on the whiteboards that are somewhere around? Bunch in the back. I'd like to see what you guys get for the others. There's some markers and the eraser things behind.
We're supposed to go, we're just writing the divergence.
Well, for, if they diverge, tell me why. If they converge, find what it converges to. All the markers are gone. So
Should I
there's
write the
some
first
behind
two
you.
terms or just?
Wash them and
That's when you start, it's going up and down. So should I? The second divergence, this is like greater than one.
Wait, which one? The Oscar.
Yeah.
That was in the first thing. Oh, yeah, I guess so, but wait, that's about
So one group says the first thing diverges because R is greater than one. What is the R value? Okay. And people are saying the next one diverges because it's oscillating. Well, the first term, when n is 1, sine of pi over 2 is 1. Now when n is 2, when n is 3, when n is 4, 5. So it goes 1, 1, 0, 0, 1, 1, 0, 0. Is C geometric? Am I multiplying by the same thing each time? No, so just showing you, there's weirdo examples. Okay. Just to see if we can get to this. Shoot, my bell is gonna ring soon. So actually, I wanna go back to this a second. To show you why Michael was right. The first term is 7/10. What we're multiplying by is 1/10, which 1/10 is less than 1, so the infinite sum is that first term divided by 1 minus 1/10. 7/10 divided by 9/10 is that 7/9. So whenever you divide by 9, 3 divided by 9, 1/3. 5 divided by 9, 0.5 repeating, blah, blah, blah. Okay. So now it's super happy fun career day. Can you guys take out your Chromebooks? There should, and go to Canvas, there should be an invitation to join by class